Today I'm going to teach you how to perform thin layer chromatography, also known as running as TLC. With your TLC plate, draw a line 1 centimetre from the bottom of your plate. This will be the baseline for our samples to run from and will ensure that they're not submerged in the solvent of the TLC jar. Next we include line markers, depending on how many samples we're running. Today I'll be running 2, ferrocene and acetylferrocene. I'm going to draw one marker for the ferrocene, a second marker for the acetylferrocene, and I'm going to run a co-spot lane whereby I spot both of the samples on the one to better visualize the separation. To spot your sample, collect a TLC spotter, dissolve your sample up in an appropriate solvent such as what you're running your TLC in, and then quickly dab your sample onto the plate. Ideally the spot needs to be no more than 1 to 2 millimeters, and you can always add extra dabs if you need more sample. I'll add the second sample with a clean TLC spotter, and again just a quick dab to load the sample. So next we need to prepare our TLC jar. Today we'll be using a 25% in ethyl acetate in hexane solution, and you need no more than 10 mils of solvent to perform this. So I have 7.5 mils of hexane, to which I'm adding in 2.5 mils of ethyl acetate, and I add it to my TLC jar. You should also include a piece of filter paper or paper towel to the back of the TLC jar, and this just helps saturate the atmosphere with the solvent, avoids evaporation from your TLC plate, which can affect the resolution. So to load the sample, you want to use a tweezers to gently lower it into the solution. When you put it in, just have a look at the solvent front and make sure it's running nice and flat. If it tends to be running up one side, perhaps speak to a demo about how you can rectify this. I'm also going to be running in 100% hexane and 100% ethyl acetate to compare what the solvent composition has, what effect it has on running the spots on your TLC. This one here will contain the 100% ethyl acetate. So this one here you can see is running up the side, and so we can rectify that by trimming the edge. Okay, so once the solvent front has reached at least 1 centimetre from the top of the TLC, it's time to remove it from the jar. It doesn't matter too much where the TLC solvent runs to, as long as it doesn't run up the top. When you pull it out, mark the solvent front so that you can calculate your RFs later on. You may have already started to notice that from each jar there's very different distances that the spots have travelled, which we'll explain in a minute. I'm going to circle the spots just to make it a bit easier to see also. Okay, so they're my 3 TLCs. On the left hand side, when I run it in 100% ethyl acetate, I get very poor separation from the 2 spots. So this means that if I was to use this solution to separate my products by chromatography, it will be very difficult to separate. The 25% ethyl acetate hexane mix has separated the product very well. I can calculate the RF values by determining the distance from baseline to the spot divided by the baseline to the solvent front. The hexane layer, although it separates the product very well, the acetylferrocene, you can see, remains on the baseline. So if this was my desired product that I would like to purify by column chromatography, it wouldn't remove from the column and I'd never get off the column using just 100% hexane. So the 25% ethyl acetate hexane is the perfect ratio for me to set up my column chromatography.